number to 40. That is search in a 2D matrix 2. So write an efficient algorithm to search for a value target in a matrix m cross n, that is m is number of rows and n is number of columns for an integer matrix. The matrix has the following properties. Integer in each row is sorted in ascending from left to right. Means for each row it is sorted in a ascending order. Okay, from lowest and greatest in ascending order. Integer and each column are sorted in ascending from top to bottom. So column are also sorted in ascending order. Column also sorted in ascending order. So similarly, row is sorted in ascending order. So you can see we have to find for the target if this target exists in this matrix, and we have to simply return to. So we don't have to care about the element position. We have to return true or false. If that element target exists in this matrix, then simply return a true. If it not exists, then we can simply return a false. So that's all about this question. What we can do to solve this. So we will simply run a loop till all the rows of the matrix, and for each row we will apply a binary search. And after applying binary search, so because for each row each a 1D matrix, so we can apply binary search in 1D matrix. So we'll run a loop till all row of the matrix, and we'll apply binary search in each row. After applying binary search in each row, if we will find the target, we'll return a true, and if we will not find a target, we will return a false. And if we have returned a true, then this will be our answer. So first of all, let's make a function to calculate the binary search. So function return type will be bool. It will return a true or false. It will check the target for each row. So we will say binary search. Function name will be bs binary search. Then we will input in the 1D vector of type integer. Let's say array. Then look for the aim. Here we will get the size of this array. Size of this array. Now let's compute int low as 0 and int high as mid minus 1. We'll simply apply a mid minus 1 now, n minus 1. We'll simply apply a classical boundary search while low is less than or equal to high, then mid equal to low plus high divided by 2. Mid equal to low plus high divided by 2. If the array of mid equal to target, if yes, we have found our answer. We can simply return true from this function. And if certain circumstances happen, for example, else if array of mid array of mid is greater than target, means mid is greater than the target and target is a small number. So we have to cut the right subscript. So I equal to mid minus 1, or else target is greater, then we will target is greater than the mid, then we will cut the left subscript, that is low equal to mid plus 1. And after doing all the stuff, after coming from the while loop, we will not find anything, then we will simply return a false, that we have not found it. So this is the function analysis. We will take the array and the aim is target which we have to find. for the binary array. The simple binary search function. So we will apply binary search for each row. So we will take the row int n equal to matrix dot matrix dot size. We'll run a row for each row int I equal to 0 and I is till I is less than I is less than n and I plus plus I is less than n and I plus plus. Okay, now we'll do a bool answer and here we will use our binary search. We'll pass the vector h matrix and the target h the target. It will return a true or false. If it's return a true, then we'll return a true. The bool is true, then this will be execute. If answer is true, answer will return a true or false. If it is true, then we can simply return a true. If it's false, then we can after completing this proof, we can simply return a false. Now let's compile this code and check for the test cases in the example. If we have got error in the function, if array of mid is equal to the target. So we don't have used any target variable, we have no problem. We modify the aim as target. No issue at all. Why we will modify everything. Now let's compile. Okay, we got an error here. We'll answer. Okay. We have to check for each row. We are passing the 2D matrix that is not there at all. So we check for all the row. So that is test cases are passed. Now let's submit and check for all the test cases. So we can see all the test cases are passed or not. Let's see. It's running test cases. So we can see maximum limit exceeded. Where we are getting maximum limit exceeded. It's a time limit error. Let's submit again and check we are getting or not. So we are again getting maximum limit exceeded. So why we are getting this? The target is this much and this is our 3D matrix. Matrix dot size I equal to 0, I less than n, will then to each row, it will get a true. So yes, we have figured out the problem. We have passed by value, so we're getting the copy of each array, so that's why it's not committed. So now let's submit and check for all the test cases. Now all the test cases are passed. Now let's discuss the time and space complexity. So what is the time complexity? We are checking for each row since it's running to big of n and we are applying binary search of in each row. So big of n into log n. So what is the space complexity? We have now to determine any extra space. So space complexity is big of 1. So that's all about this. Thanks.